What is a graph? A graph is a data structure made for displaying the relationship between many or one entities. Entities are usually connected through lines that are called edges, and entities are represented as nodes or vertexes within the graph. Relationship can be a directed graph or a graph that is undirected, meaning that there is no hierarchy or order to the comes. For an example, an easy to understand example would be understanding a friend group. The friends would be all different nodes. Edges would be relation between friend groups. If one node is connected to another node, that would make them friends. Let's assume person A is friends with person B, but person B is not friends with person C. Let's assume person A is friends with person C. This would mean there are two edges that connected to person A, meaning they have two friends. While person B and C are not connected directly, they are friends of friends, which represents this relationship. There are many different ways to measure relationship between two nodes. For example, there's a graph representation that allows you to weigh the relationship between two nodes. This is called a weighted relationship. The implementation of a graph algorithm, there are many key components to understanding and using a graph effectively. One is what we've already described is a node or vertex, which represents an entity. Another is an edge, which we've already talked about, which is the relationship between a node. An edge can be weighted or not. Additionally, there are counts associated with each node if a graph is directional. If the graph is directional, there is an in degree, which counts the number of relationships coming towards the node / vertex, while there is an out degree, which counts the amount of relationships leaving the node. A way to describe relationships between one or many nodes is also called a path. A cycle is just a path that starts and ends at the same vertex node without repeating the node or edge in the path. Graphs have a lot in common with trees, but are uniquely different. Trees have a root node that is the starting point of the tree, while graphs are a collection of nodes with no starting point. Graphs are pretty time efficient, since the time complexity of graph is predicated on the amount of nodes and edges within. So in big O notation, the time complexity can be represented by the amount of vertices / nodes and edges that is passed through. So if we were to let n represent the total nodes and e the total edges, the big notation would look as follows. O of n plus e. Since n and e are constants, we would be able to determine the size of the graph based on big O notation, and we can reduce it to O of C, C representing the total nodes and edges traversed. All right, let's set up a problem with the graph data structure. Since there are already many graph examples developed by smarter
created using Powtoon.